Welcome my dear students to your Maths online class, and in my previous class I have explained you about HCF, highest common factor, and according to that topic I have given you the assignment to solve two questions, in which first question I have given you to solve according to prime factorization method, and in second question I have given you to solve it according to long division method. The solution of these parts are given in your PDF also. Here also I am explaining you, so please pay attention how to solve it. I hope you have done it correctly, so please check your solutions. Now, in prime factorization method I have told you that we have to find the prime factorization of the given numbers separately. So first of all we have to find the prime factorization of 27 here, and I have told you that we have to start from the smallest table, that is from the table of 2. But we know that 27 doesn't come in the table of 2, so we will start by the table of 3. Yes, in the table of 3, 27 comes, it comes 9 times. So 3, 9 times 27. Then again 9 comes in the table of 3. So 3 into 3 is equals to 9. Again 3 comes in the table of 3. So 3 ones are 3. So we have to solve it until and unless we get 1 at last. Then the working of this we have done. Now we have to find the prime factorization of 64. So by the table of 2, because the last digit is 4. So 2, 3 is a 6 and 2 2 is a 4. So 64 comes 2 times in 64 comes 32 times in the table of 2. Again it will come in the table of 2 because 2 comes at the last. Then in the table of 2, 32 comes 16 times. 2 ones are 2, 1 carry over 12 and 12 comes 6 times. Again in the table of 2 it comes 8 times. Again in the table of 2 it comes 4 times. Then again in the table of 2, 4 comes 2 times, and then finally again in the table of 2, 2 comes 1 times. Now we have to write the factors. Here the factors of 27 are 3 into 3 into 3, and the factors of 64 are 2 into 2 into 2 into 2 into 2 into 2. That is 6 times number 2 is coming. Now we have to find the highest common factor. You can see here now students that no number, no factor is common here, because here all 3's are there and in 64 all 2's are there. So nothing is common. So whenever such situation comes with us that no number comes common, then what happens? Common factor is considered as 1. Number 1. When nothing is common, then we consider it as 1. Therefore, the HCF of 27 and 64 will be 1 here. So the answer will be 1. Okay, I hope you have done it correctly, and if suppose you have got confusion, then please clear your confusion here, that whenever no number is coming common, then the answer is 1. Similarly, we have to do the B part. Here the number is 85. You can see that the last digit is 5, which is not coming in the table of 2. So we will check it by the table of 3. And in the divisibility, I have told you that the divisibility of 3 is to check the numbers. So add 8 and 5. So 8 plus 5, yes, it is 13. So 13 doesn't come in the table of 3, no. So this number is not coming in the table of 3. Then we have to check it by the table of 4. No, in the table of 4 also this number doesn't come. Then we will check it by the table of 5. Yes, in the table of 5 it comes, because the divisibility of 5 is the last digit should be 0 or 5. Right now we can see 5 is there. So we will solve it by the table of 5. See, in the table of 5, 8 doesn't come. Smaller than 8 is 5. It comes 1 time. So from 8 we have used only 5. So 3 carry over. So now this 5 becomes 35, and 35 comes 7 times. If directly you cannot solve, then you can divide it. Then 17 is a prime number, so it comes only in the table of 17. So we will directly solve it by the table of 17. 17 ones are 17. Here second number is 102. So last digit is 2. We will solve it by the table of 2. So 2 outside. In the table of 2, 10 comes 5 times and 2 comes 1 times. So 51. Now 51 doesn't come in the table of 2 because the last digit is 1 here. So after 2 we have to check it by the table of 3, and the divisibility of 3 is to add the given number. So 5 plus 1 is equals to 6. Yes, 6 comes in the table of 3. That means 51 comes in the table of 3. So 3 will come outside, and how many times it comes? Either you can divide it 51 by 3, or directly you can solve 3 ones are 3 to carry over 21, 3 sevens are 21. So 17 times. And then finally 17 ones are 17. So here we have solved it. So the factors of 85 are 5 into 17, and the factors of 102 are 2 into 3 into 17. Here you can see the common factor is, yes, it is 17. So our common factor is 17. That means the HCF is 17. The HCF of 85 and 102 is 17. I hope you have done it correctly. Now, the second question I have given you to find the HCF of these three numbers by long division method. And I told you that we have to solve it stepwise. So in step 1, first of all, we will find the HCF of two smaller number. And here the two smaller number are 48 and 72. So here we will put 72 inside the division format and 48 outside the division format. Now 48, 1 time 48, because 2 times it will be 96, it will be greater. So we will take 1 time only. Subtract it. After subtracting you will get 24. Then 0 is not the remainder, so it will continue. So we will make the division format again here with remainder, and now this 48 will come here inside. So 48 inside. In the table of 24, 48 comes 2 times. So 48 here, 48 minus 48 is 0. That means 24 is the HCF of first two numbers. Now with this HCF, in step 2, we will find the HCF of this number, the result of first two, and the third number which is given in the question. So 24 and 96. Now again the greater number will come inside the division format and the smaller number will come outside the division format. Now 24 4 times is 96. Okay. So 4 you will write outside and 96 here. So here we have got the remainder as 0. That means this 24 is the HCF of 48, 72, 96. That is 24. Okay. And in the second part of the long division, I have given you 121, 33 and 605. This number I have given you. So again, in the step 1, we have to take the two smaller number, that is 121 and 33. So make the division format, take the greater number inside the division format and the smaller number outside the division format. Here we have to divide 121 by 33. So 33, 3 times is 99 and 33, 4 times, 4 3 is a 12, 4 3 is a 12 plus 1, 13. So 4 times it is greater, so we will be taking 3 times. So 3 times we will take here 99. So 11 minus 9 will give you 2, and here also 11 minus 9 will give you 2. The remainder is not 0, it is 22. So the division will continue. Now this 33 will come here down, 33 inside. In the table of 22, 22 ones are 22 and 22 twos are 44. So we will take 1 time only 22 here. Now the remainder is 11 after subtracting. Again the remainder is not 0. So our division format will continue. Now this time this 22 will come down. The previous divisor will come down. So 22 will come inside the division format. Now in the table of 11, 22 comes 2 times. So 11 twos are 22. So here the HCF of the first two number, that is 121 and 33 is 11. Now in our step 2, what we will do? We will find the HCF of 11, the result of first two, and the third number which is there in our question. So the result of first two number is 11 and the third number is 605. So we will find the HCF of 11 and 105. Okay. 605. Now this 605 will come inside the division format and 11 will come outside the division format. Now start dividing it. So 11, 60, we will take two numbers firstly. 11 5s are 55. So 60 minus 55 will give you 5. Bring this 5 down. 55. 11 5s are 55. So 55 minus 55 is equals to 0. That means the HCF of 121, 33 and 605 is 11. So this is your answer. Okay students. So the answer key is given in today's PDF on page number 1, page number 2 and on page number 3, which you have to copy in your practice notebook. Fine. Then today I am explaining you about the new topic, which is LCM. Yes, in previous lecture I have explained you about HCF, highest common factor. Today you will learn about LCM, which is least common multiple. Okay, that was factor, this is multiple. See, the LCM of two or more numbers is the lowest of their common multiple. We can find out the least common multiple for any set of numbers. We can find the LCM of any number. And again, there are two methods of finding LCM. The first method is again similar as the HCF only, prime factorization method, and the second method is division method. It is also, the names are similar in both the topics, okay, prime factorization method and division method. So here the way of doing is somewhat different. So pay attention, I am explaining you here. Here, firstly I am explaining you LCM with the first method, that is prime factorization method. See students, the explanation of today's topic is given on page number 4 and page number 5 of your PDF, but don't copy these two pages, only copy the assignment pages. Okay, that is today you have to copy page number 1, page number 2, page number 3 and then the page number 6 where I have given day 12 assignment. So firstly I am explaining you here LCM and the topic prime factorization method. This I am explaining you, and the example which is given in the PDF also same example I am taking here. The example is 72 and 42. So we have to find the LCM of these two numbers. See, same way we have to firstly find the prime factorization of both the numbers separately. See, you can see that 2 is there at the last. So both the numbers are coming in the table of 2. So first of all we will solve it by the table of 2. In the table of 2, smaller than 7 is 6, it comes 3 times, and then 1 carry over 12, it comes 6 times, 36. Then 36 comes 18 times in the table of 2, 18 comes 9 times in the table of 2. Now this 9 doesn't come in the table of 2. So we will move on to the next table, that is the table of 3. So 9 comes in the table of 3, yes, it comes 3 times. So 3 3s are 9. And finally again 3 comes in the table of 3, 3 1s are 3. So here we have come up with the result 1. So here our 72 prime factorization is done. Now move on to 42. 42 comes in the table of 2, 4 comes 2 times and 2 comes 1 time. Then 21 doesn't come in the table of 2, so we will check it by the table of 3. Yes, it comes in the table of 3, it comes 7 times in the table of 3. So 3 7s are 21. Then 7 is a prime number, so it will directly come in the table of 7. 7 1s are 7. Now what we have to do, we have to write the factors of 72 and 42 separately. So the factors of 72 are 2 into 2 into 2 into 3 into 3. And the factors of 42 are 2 into 3 into 7. See students, what we have done in HCF, we have taken the highest common factor there. Here also we have to firstly circle the common numbers. So 2 and 2 is common here and 3 and 3 is common here. Suppose the HCF was asked in the question. So the HCF of 72 and 42 will be what? 2 into 3, because 2 is coming common and 3 is coming common in both. So 2 into 3 is equals to 6 will be the HCF. But here we have to find the LCM, least common multiple. So what you will do? Firstly, you will take one number from these common numbers. So 2 and 2 is common. So from this 2 and 2, you will take only 1 2. Okay. Then the remaining values, the remaining numbers which are not circled, that also we have to include in LCM. In HCF, we were involving only the circled number, but here in LCM, what is the change? You have to take the common number and then you have to take all the remaining numbers also which are not circled. So after 2, these 2 2's are not circled, so we will be writing these 2 2's also. Then the number 3 is circled. So from these 2 3, we will take only 1 3. The common values you have to take only one time. Don't write it 2 times. Then 1 3 is remaining and then 1 7 is remaining. So that also we will write. Got it, student? Be careful. From these 2 2's, we will take only 1 2. Then the remaining 2's also we have to take here in LCM. LCM we take all the numbers which are remaining. So 2 and 2 will come. Then from these 2 3, 1 3 will come. Then the remaining 3 and the remaining 7. Now you have to multiply all these numbers, and when you will multiply, you will get the result 504. Okay, students? I hope you must have got it. Don't get confused between HCF and LCM. The results will come different in both the cases. You have to understand the concept. Now here I am taking one more example for finding the LCM by prime factorization method. In PDF I have given only the one example, but here I am explaining you by one more example. That is, the numbers which I am taking here is 35, 55 and 95. So first of all, as I have told you, we have to find the prime factorization of these numbers separately, 35, 55 and 95. Yes, these numbers firstly are coming in the table of 5. So in the table of 5, it comes 7 times, and then in the table of 7, it comes 1 time. Then 55, in the table of 5, it comes 11 times, then it directly comes in the table of 11 because 11 is a prime number. Then 95, yes, it comes in the table of 5, 5 ones are 5, 4 carry over 45, 5 9s are 45, and then 19 is a prime number, so it comes directly in the table of 19. Then what we have to do, we have to write it like this: 35 is equals to 5 into 7, 55 is equals to 5 into 11, and 95 is equals to 5 into 19. Okay, students? Now, you can see that what is coming common here? Yes, number 5 is coming common here. So, we will take number 5. If suppose it is HCF, then our HCF will be 5 only. But this is not HCF, this is LCM. So, we will take circled number one time, and then all the numbers which are not circled, that also we have to take. So, here 5, then 7, then 11, then 19. All the uncircled number will also be included. So, multiply all these number, you will get your LCM. So, here after multiplying, you will get the result 7315. So, this is your LCM. Okay. So, this is the method called prime factorization method. Now, I am explaining you the next method, that is the division method to find the LCM. And the example which I am taking here is the 4 numbers 14, 35, 56 and 105. This example is given in your PDF. See student, for finding the division method, what we have to do, we have to make one common format for finding the prime factorization of these numbers. We will not find it separately, we will take it in common. Then we have to move with the smallest table. Here you can see that firstly we will be checking by the table of 2. So 14 comes in the table of 2 and 56 comes in the table of 2 because 4 is there at the last and 6 is here at the last. Yes, 14 comes 7 times in the table of 2. 35 doesn't come in the table of 2. So what will happen? This 35 will come as it is here down. No change because it doesn't come. So if any number doesn't come in any particular table, then that number we have to take as it is. Now divide this 56 by 2. So what you will get? You will get 28 here. Then 105 again doesn't come in the table of 2, so it will come as it is. Again we have to firstly check that any number comes in the table of 2 or not. 7 doesn't come, 35 doesn't come, 105 also doesn't come. But 28 comes because the last digit is 8 here. So we will solve it by the table of 2 only. Until and unless we will not finish one table, we will not move on to the next table. So 7 will come as it is because it doesn't come. 35 will also come as it is because it doesn't come. And 28 comes 14 times. So 2 ones are 2, 2 fours are 8. And 105 will come as it is. Again by the table of 2 because 14 comes in the table of 2. So see what you have to do. 7 will come as it is. 35 will come as it is. And then 2 7s are 14. 105 as it is. Then what you have to do now? By the table of 3, you have to check now. Then you can see that 7 doesn't come in the table of 3, 35 doesn't come in the table of 3, 7 doesn't come in the table of 3, but 105 comes in the table of 3 because 5 plus 1 is equals to 6. So we will solve it by the table of 3. 7 as it is, 35 as it is, 7 as it is. Now 3, 3s are 9, then 15, 3 5s are 15. Now it comes in the table of 5 because 35 comes in the table of 5. 7 as it is, 7, 5 7s are 35, again 7 as it is, then 5 7s are 35. All 4 7s are there and it comes in the table of 7. So 7 1s are 7, 7 1s are 7, 7 1s are 7 and 7 1s are 7. So now the LCM will be 2 into 2 into 2 into 3 into 5 into 7. When you will multiply all these numbers, you will get result as 840. Remember students that you have to move sequence wise. When you are doing the division method, just move sequence wise, use the table sequence wise to solve your sum. So this is about the division method. So here I am explaining you this second method, division method, with the same example which I have taken in the prime factorization method. That was 35, 55 and 95. So see, firstly by the table of 5. So 5 7s are 35, 5 1s are 5, 5 1s are 5, then 5 1s are 5 and 5 9s are 45. Then by the table of 7, 7 1s are 7, 11 as it is, 19 as it is. Then by the table of 11, because 11 is a prime number, directly it will come in the table of 11. And then finally by the table of 19, 1, 1 and 1. So the numbers which we have got there, the same number we will get here in division method, 5, 7, 11, 19. You can see by prime factorization method also we have got 5, 7, 11, 19, and by division method also, because we are finding LCM only, so the result will same only, 7, 3, 1, 5. So this was all about today's topic, LCM. That is, I have explained you prime factorization method. This is the prime factorization method, and then this is the division method. I hope the topics are clear to you. So just go through the complete video again to understand the topic well, and then after understanding you have to solve the today's assignment. And I have given you 2 questions in today's assignment. First is to find the LCM by prime factorization method. Of these 2 parts you have to find LCM by prime factorization, and the next 2 parts of question number 2 you have to solve it by division method. Okay students, so try to solve it by yourself. Then in my next video I will give you the solution of these 4 questions again. Okay, so just go through the video and understand the concept properly. Fine, so that's all for today. Now I will meet you all in my next video. Till then, go through the video, understand the concept of LCM and HCF again and again, and please don't get confused between both these 2 methods. Okay, see, these 2 methods are very important for you all. Okay students, so meet you all in my next video. Till then, take care of yourself. Thank you students.